Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this equation. We are required to find the value of z in form of a plus bi in rectangular form, considering that z is a complex number. We are given a determinant of absolute value of z, 1, conjugate of z, 2 equal to 2 minus 2i. Okay, first, what do we know? Is that if z is equal to a plus bi, then that implies that its conjugate is equal to a minus bi. So that's the value of its conjugate, and that's implies the absolute value of z, which is the magnitude. It's defined as square root of the real part squared plus the imaginary part squared. Okay, so this is what we have to consider. Then replacing it there, we're going to have square root of a squared plus b squared, 1, and then we have a minus bi, because it's the conjugate of z, and then we have 2 equal to 2 minus 2i. Okay, we can apply now the condition for the determinant. When we're calculating, we multiply the main diagonal minus the multiplication of the second diagonal. Okay, the product of the second diagonal. So we multiply this by this one, so we have 2a squared plus b squared, and we multiply this, we have minus a, this becomes positive, so equal to 2 minus 2a. You know, the negative of the formula enters inside, so it changes the sign of the expression inside the bracket, so it becomes minus a and plus bi. Okay, now we just have to equal the real part to the real part and imaginary part to the imaginary part, because it's equality of two complex numbers. So this implies that we're going to have 2 square root of a squared plus b squared minus a, because this is the real part of this complex number, being equal to 2, and b equal to negative 2. We're equaling the imaginary part. So if that's the value of b, then we just substitute here to find what's the value of a. So this is the value of b. Then this implies that we're going to have 2 square root of a squared. B is minus 2, so that means b squared will be 4 equal to 2 minus a, minus a equal to 2. Okay, now to find the value of a, we can isolate first the square root expression. So 2 square root of a squared plus 4 equal to 2 plus a. Squaring both sides, we're going to have 4 a squared plus 4. Here we're going to have 4 plus 4a plus a squared. Okay, now we can send all this expression to this side. So we're going to have 4a squared plus 16 minus 4a minus a squared minus 4 equal to 0. Then this is going to be equal to 3a squared minus 4a. 16 minus 4, it's going to be 12, so it's going to be 12 equal to 0. Solving this problem, we're going to have a will be equal to 4 plus or minus square root of 3 squared minus 4 times a, which is 3, times 12, which is c. Okay, over, the value of b, it's minus 4, so it's going to be 4 squared. It's equivalent to write 4 squared times 2 times 3. Okay, this is 16 squared minus 4 times 3, which is my value of a, the coefficient, which is going to be 12. 12 times 12, it's going to be 144. Let's just do a quick calculation. 144 minus 16, what do we get? We can borrow 1 from 4, this becomes 3. This is 14, and when we subtract 14 minus 6, we get 8, and 3 minus 1, we get 2, and we keep this one. So 128, but it unfortunately will be negative. So a will be equal to 4 plus or minus square root of minus 128 over 6. So a will be equal to 4 plus or minus 8 square root of 2i, because it's negative, over 6. If we factorize 4 on top and 4 on and we simplify with 6, we're going to have, we can just factorize 2. Here will be 2 plus or minus 2, no, here will be 4, square root of 2i over 3. So that's the value of a. We have b value and we have a, but a is plus or minus 1. So what we can do, we can say we have z1, because we can work with the positive, no? We can work with the positive, which is 2 over 3 plus 4 square root of 2. The value of b is negative 2i, and z2 will be 2 over 3 plus minus 2 minus 4 square root of 2i. So we have those two values for z1 and z2. Okay, perfect. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.